Welcome back. So, up till now we have considered a simple schematic for an open system. So, let me draw that again here, and because every time I come here and draw, the open system will look slightly different, but that does not matter. We are drawing an arbitrary open system with one inlet and one outlet. So, let me just draw it again. So, this is my open system now for today, and this is the inlet and this is the exit, and it is interacting with the surroundings and having some kind of heat and work transfer with the surroundings. So, we will have our usual convention, we will draw a q dot. So, this is heat transfer per unit time. So, it is a heat transfer rate that we are considering. Similarly, we will draw a w dot. This w dot you will notice often is given a subscript s. We will come to the subscript s later, but let me just put it along here. And this w dot, that is this work transfer, is work done by the system. We will follow the same convention that work done by the system is positive, and we will draw it similarly here. This work includes all kinds of external work, expansion work, stirrer work, electrical work, anything that can be done to the system or by the system, except to push fluid in and out of the system. So, for example, this is an open system and mass crosses in and out of the boundaries. So, there is some effort required in pushing the mass in and some effort required in pushing the mass out. That is not considered in this w dot. Now, to analyze this system, one will realize that it is easier to go to a closed system and make an analysis, and it will also enable us to understand what is this extra work involved in pushing in the fluid and pushing out the fluid. And to consider this, what one does is, apart from this system that we have considered here, which I will label as CV for control volume, we will also consider two plugs, and this is what we will name as an inlet plug and an outlet plug. So, let me just put this here. So, I have drawn an inlet plug and an outlet plug. So, what are these plugs? So, one should consider closed system with this control volume and one of the two plugs. And why is that? Let me just tell you. Consider that there is some mass in the control volume, and at time t it is here at the exit. At time t plus delta t, some part of the mass moves into the shaded region at the exit. And of course, this will depend on what is the area at the exit, what is the velocity at the exit, what is the density at the exit. So, this is the amount that will come out in the exit, and we are going to consider this as what is called as the exit plug, that is all the mass that has come out of the system through the exit, okay, in the small time delta t that we are considering from t to delta t. Similarly, the inlet plug is something where mass is entering the system from time t to t plus delta t. So, this is what it is here, this is t, this is t plus delta t, and this is the amount of mass. This hashed region here is the amount of mass that enters the system, the control volume, in a small time delta t. So, these are the plugs which determine how much mass enters the control volume and how much mass exits the control volume in a small time delta t. Now, you will notice that we have considered a control volume which is probably not changing its volume with time. That is fine, we can always extrapolate it and make it change with time. These two plugs are not part of the control volume, but we have added them, and you will realize that we can create a closed system with the control volume and one of the plugs. So, for example, I can have a control mass system, okay, that is a closed system where I will say it includes the volume in this control volume. So, this is unshaded part is the control volume, and I will take at time t the closed system to include the CV, that is the control volume, plus the inlet plug. So, this is what is included in the inlet plug. Now, you realize that at time t plus delta t, whatever mass is here would have gotten up to here, and we will assume that there is there is no mass which is transferring across this boundary. Every mass that was considered up to this point, that is here, and it occupies all this volume, and whatever some mass is here, it occupies now some of this volume here in this exit volume, all the volume in this exit volume. So, the same mass which was occupying the control volume plus this inlet plug at time t now occupies the volume control Cv plus this exit plug at t plus delta t. So, in essence, what we have is a closed system which includes Cv plus the inlet plug at time t, and it is the same closed system without any transfer of mass across the boundaries if we consider at time t plus delta t the Cv plus the exit plug. So, this is the closed system that we will consider, and you will realize that you must have a neat look at this system before we go ahead and try to analyze what happens to conservation of mass and also the conservation of energy. So, we will take that up in the next snippet. Thank you.